Now I have to actually talk about the something called Big Data Ecosystem. So rather than talking in general, I have to tell you what are the products we use, where we use them, and why we use them. All right? And you need to have a rough idea about them. Like if you hear the name, you should say, okay, this is what I'm using. Now, in order to explain that, what I'm going to do, I'll pick up a use case. That's better. I will pick up a use case which we were working, and that will cover most of the products, at least majority of the products, right? So the use case we had was the migration of ICICI Bank in 2012. ICICI Bank had migrated from their traditional platform to Hadoop back in 2012. And at that point in time, my company was the major consultant for them to migrate. The migration actually took 2 years almost, and later the support was changed. I was also part of the team which did the migration. I didn't do the complete migration or something, but I knew how it was happening, like which were the parts which were migrated and all. So I'm just going to take the same scenario so that we can understand what are the tools that are actually involved, right? So you are migrating to Hadoop. So that means Hadoop is there. So first thing is that Hadoop is there for sure, because for managing big data, you have Hadoop, right? In Hadoop, you have something called Hdfs. Just write it here. You have something called Hdfs. So Hdfs stands for Hadoop Distributed File System. Or basically, this is the file system which helps Hadoop to store the data. So when you build a Hadoop cluster, let's say you are using 100 machines, okay? What Hadoop will do, it will combine all these 100 machines into a single file system called Hdfs, right? So I'm just drawing Hdfs here just to tell you that Hadoop is there and the storage part is handled by Hdfs. And imagine we have a cluster there, okay? Now the first challenge we had was that ICICI Bank had this core banking. Core banking is where all their transactions are there, credit, debit, everything, right? And this core banking data was actually in an RDBMS, that was Oracle. So they were using Oracle to store all the core banking data. And Oracle is very reliable and all, you know that, right? Now our challenge was that, so they already gave us the backup of this data. We already had the backup, like last month till date backup data and all, and we copied that to Hadoop. That's not a big deal.
Of only this, because we had a combined data actually. I mean,
but once you're having an archival system as well.
I was not actually in this part. I was not involved in their core banking migration. So I didn't know the exact size, but they were migrating. So this was done in phases actually, because it is a very complicated migration.
So we had a lot of people working on them. And I was actually part of a technique called Kafka. There is somebody called Kafka. I was managing Kafka queues. That was my role. Okay. So I don't exactly remember what was their DB size, but the backup was easy because they will give you the backup, you will copy it, that's done. But then the requirement, they came up with something very weird. What they said, so this migration will happen in a way that you will migrate all the data from here to Hadoop, right? And this system will remain. Now, one thing you need to understand is that nothing on earth can replace RDBMS in another 100 years or 1,000 years, give or take. So many people have this question, okay, so now big data is there and so many other technologies are there. That means RDBMS is losing its significance. No, absolutely not. Nobody can replace RDBMS. Because RDBMS is the only system which gives you consistency. You know what is an RDBMS anyway, right? Acid properties. So for the core banking, still they are using the same Oracle DB.
And nothing can beat it. There is no system on earth which can beat it.
No, but the reason they are still using it, because if somebody has to migrate to another database, it takes a lot of time and effort and money.
Fine.
But if today somebody creates a new application, they will not choose to use the
RDBMS, yeah, he's right.
They will use the NoSQL database. There are much reliable NoSQL databases out there.
No, I will come to NoSQL in a moment. But I feel still they will use RDBMS. You will use NoSQL for sure, but for a different set of aspects. If you are creating, let's say, a financial database, you still prefer RDBMS.
SAP moving from Oracle to HANA. HANA is a node-based database only. They won't provide a database.
Correct.
Because of huge volume, the Oracle is costing more. SAP is already moved. Even all SAP customers, they're forcing to move to HANA.
Right.
So that's why.
But HANA is again like normal, what you say, table-based database.
No, it is not a table-based. It's a clustering-based database. Their own proprietary database.
Correct. Clusters are there, but end of the day, you are using SQL only, right?
I don't think we have SAP uses their own retrieval procedures from their side. They
Okay, but how do you write the queries and write?
Queries and also the backend will not be open for you.
Mm-hmm.
So there is a code name. I mean, ABAP. You have to write your
ABAP,
similar kind of a code procedure for that.
Okay.
You can't directly touch the SAP databases.
Now, my point is,
If you look at financial data, right? In financial data, your problem is with consistency, right? One thing is consistency and all the asset properties, atomicity, consistency and all. And RDBMS is the only system which provides asset properties. When you go to NoSQL, NoSQL actually does not work on asset properties. There is something called base. NoSQL works on something called base properties. Well, it is different. I mean, NoSQL is also reliable, but if you go to financial side, people don't actually prefer NoSQL. Mostly either RDBMS or not the pure NoSQL that we say, like MongoDB or Cassandra, those things. So ICICI Bank and many of the financial customers still use either DB2 or Oracle or any of the RDBMS systems. So what they wanted to do, if a customer is, again, the same situation, swiping his card in a particular merchant, and if the amount is more than a particular amount, he should get an SMS with an offer. Say, you bought jewelry for 1 lakh rupees. The moment you swipe, you should get a message saying that, again, if you purchase jewelry, you will get 20% or 30% off. That was very new at that point in time. Now, whichever new data comes in Oracle, probably every day, midnight or something, we will copy the data. Not a big deal. But then the bank said, no, that's not our requirement. Whenever there is a transaction happening here, using a card, not an online transaction, using a card, but transaction has to be captured in real time, right? And then a decision has to be made, whether you should contact the customer or not contact the customer, etc. Now the problem is, this Oracle is their core banking database, and they will not allow you to touch this. Nobody will allow you. Correct, because that is their primary database where everything is happening, and we agree the condition that you are migrating to Hadoop and all, but they will never say that, okay, we will open our Oracle for you, you can come and do whatever you want. No. So the point is, they were using this guy called Golden Gate. You might have heard about it. There is somebody called Golden Gate. Golden Gate is basically sort of like a replication system that, replication management that Oracle does. It is a proprietary product. You pay millions only for Golden Gate, but very reliable, right? And this comes under the category of CDC. Have you heard this term? Change data capture. Meaning, what is this Golden Gate doing? If there is any modification in data here, a log file will be created here for that. So if somebody want to understand what is happening here, you go and ask this guy. He will give you a log, and if you can read and understand the log, you know what is happening. So if I have the backup and this log file, I know what is the current state of the DB. And this is very common everywhere. It's not only in this situation, it's very common. A lot of people use cheaper CDC solutions. Golden Gate is very costly. In fact, in GE and all, they use a very cheaper CDC, not Golden Gate. GE uses Greenplum as their data warehouse. Greenplum is the data warehouse. And for replication, they use, I forgot the tool's name, but it is very cheaper, not like Golden Gate. But ICICI Bank was actually using Golden Gate and CDC. That means now if somebody is swiping their card, the data comes here, and immediately I have a log file here. So I need to figure out a way to get the log file from here to my Hadoop, right? So I need an effective way in which whenever there is any new log data getting generated here, I need to bring it here. That is where I will be using a tool called Flume. So this is important. Flume. Apache Flume. So when you discuss Hadoop, it is like you're discussing about a mobile phone. So let's say somebody comes to you, okay, who was in the jungle for like past 30 years, who has never seen the light of the day, right? He comes to you and says, he looks at your smartphone and he's asking, what is this? So you will say it's a smartphone, okay? And he will ask, so let's say he's a bit intelligent or something. He is asking on what platform and all it is running. So you will definitely say it's an Android phone or an Apple phone. But then his next question was, is it just having only Android or Apple? No. So if I look at my phone, let's say I have an Apple iPhone, okay? So Apple iPhone has a platform called iOS. But on the day-to-day lives, we also use a lot of other apps like WhatsApp or Facebook, or to book a cab, you use Ola or Uber. So today when somebody say a mobile phone, it has a platform and then the apps on top of that. So Hadoop is very similar. Hadoop has a platform where it will allow you to store the data, no doubt about it. Then it has n number of apps you can use for day-to-day activities of analyzing and bringing the data. Hadoop alone is not very powerful, because if somebody is using Hadoop only, they're just storing the data and they're not really concerned about analyzing the data. So when you want to feed the data or analyze the data, you use a lot of apps. We can say apps. It's called ecosystem tools technically. So Flume is one such app or a tool which commonly we find on top of Hadoop. And what is the purpose of Flume? It is used to collect log data from source to destination. So typically, if you are using Flume, this guy can take the data and then simply give it to Hadoop. So Flume is an open source project, Apache. Even Hadoop is open source, Apache. All these are open source products. So no money, nothing, free. Not 100% is free, but you can say it is free. It's open source, all right? So we implemented Flume so that whenever there is a log file getting generated here, this guy will pull it and he will immediately make it available in Hadoop. But that did not solve the problem, because my problem was that I don't want to get the data to Hadoop. I want to understand whether it is happening in real time, and if yes, if this card swipe is for 1 lakh rupees or something, I want to send an SMS. That is my requirement, right? So this was not exactly what we did. This is ideally what you can do with Flume. From Flume, what we did, we got the data, we send the data to somebody called Kafka, another guy. Now, I will use a lot of terms, don't worry. So you don't have to by heart it, like there is no exam where somebody will ask what comes after Flume. Is it Kafka or Flafka? So there is nothing like that. Okay, so just understand what it is, right? So from Flume, what we did, we took the data and sent it to another guy called Kafka. Now, what is this Kafka thing? Kafka is a message queue. Anybody aware of what is a message queue? So when you post something in Facebook, say 10 people can read it or 10,000 people can read it, as long as it's public to them, right? Same way, if I publish my data to Kafka, multiple people can actually read the data from Kafka at the same time. So the industry use case of Kafka is this. So let's say you are having multiple projects in your company. So let's say we split into 3 groups. So let's say we are working for a company, right? And there are 3 projects in the company. All 3 projects are working on social media data. So what I can do, I can download the social media data and keep it in Kafka. And all of us can connect with Kafka and get the data. So otherwise, what I should do, every team should separately, connect with social media and get their own data. So Kafka will provide like a common platform. From there, anybody can connect and get your data. So, and why we were using Kafka, that is a question, right? So from Flume, it will go to Kafka. From Kafka, for doing real-time analysis, we were using something called Spark streaming. Spark streaming is the guy who is going to do this real-time analysis. Like this guy will read the data and decide, whether the message has to be sent, not sent. All the analytics is inside something called Spark streaming, right? Now, why I was using Kafka? Because once the data is in Kafka, one copy Spark can get to do real-time analytics. Another copy I can send here. That is why I'm using Kafka. Flume is point-to-point delivery. If I'm using Flume, only one. Flume is like you're sending a personal WhatsApp message. You send it, another person receives it. Kafka is like you're putting something in a Facebook bot. Anybody can get it. Also, in future, ICICI Bank, what they wanted to do, they wanted to build a machine learning model based on this data. So if they're building a machine learning model, the machine learning model also can get the data from Kafka. Multiple people can consume. So they wanted to expand on this. So that is why they said from Flume, send to Kafka. Okay. From Kafka, let's say everybody can consume and get the data. So what we were doing, this will go to Spark streaming. Here all the analysis will happen, whether somebody should send an SMS, not send an SMS, and Spark streaming will take care of the part. Now the question, if this is so efficient, why are you using Flume, right? From here I can directly send to Kafka, right? Why do you plug this in the middle? Right, that is a question. There is a reason. So again, this is in 2012 or 13. Now the architecture has changed. Kafka is based on something called a push approach, meaning somebody should push the data to Kafka. It cannot get it. Or in the worst case, let's say I don't want to use Flume at all. I must stick with Kafka. Then what I need to do, I have to go to this Oracle DB or Oracle Golden Gate, and I have to write a program to push the data, which ICICI Bank will not allow me to do. Because they will say we will not allow you to change the existing setup. Okay. So Flume is pull-based approach, which means whenever a log file is getting generated, Flume will automatically pull it. Nobody knows what is happening. Once Flume get it pushed to Kafka, Kafka will get it. Once it is in Kafka, everybody can get it. Now, in the recent changes, like past 3-4 years, this architecture has changed a lot. In the recent versions of Kafka, Kafka can also pull now. It was not there in 2012, but the recent versions of Kafka, there is something called Kafka Direct, where it can pull the data. It is possible to directly pull the data. But yeah, so this was what we were doing. So we were using Golden Gate, then Flume, then Kafka, then it will go to Spark streaming. And there the real-time analytics will happen, whatever.
So how the data was getting stored in the Hadoop file system? Because the data is coming from the RDBMS.
From Golden Gate, yeah. Log files, text log files.
So the text log files will go to the Hadoop file system?
Yes, Hdfs. And we were doing analytics only on the data. I mean, the bank wanted to do analytics, so they were okay with any format. Because once I have the data in Hadoop, I have different tools which can read the data. So whether the data is in a table format or a text format, I have a way to read it. So they just want the data to be present here.
First thing is that Flume is point-to-point delivery. Like it will take data from here to here. It cannot say point to multi-point delivery. Second, the difference is Flume is originally pull-based approach. I mean, you give a source for Flume, it will automatically start polling the source and pulling the data. Kafka is push-based. Somebody should give the data to Kafka, push the data.
You need a source which can.
Kafka is taking pull also, right?
Kafka is
Taking pull also now.
now it is taking pull-based approach. This was
Now there is no use of
So yeah, so now if I'm building this architecture, I don't need Flume. Kafka can directly pull it. There is something called Kafka Direct, which will actually give me the data directly and get the data. But again, Flume is used a lot these days. So there are situations where you don't need Kafka. For example, my interest is just downloading tweets. Imagine you're building a system where you are downloading data from Twitter, tweet data. I can use Flume. I can say Flume, connect with Twitter, get me the data. I don't need Kafka. Flume will get the data to Hadoop. Why should I use Kafka? Maybe I only want the data. I'm not ready to share. Maybe I'm bad. Okay, so I can just say that I'll use Flume. I don't need Kafka in that place.
yeah. So
only one input, multiple output.
one input, multiple output.
Now, Kafka is much more complicated. There is a separate course called Kafka. Okay, so In Kafka, there is something called topic. Topic is like a queue. Like in the same architecture, let's say somebody else is sending data to Kafka. How do you know the difference? This data is coming, that data. So you will create something called a topic. That's like a queue. So if this guy is sending the data, you will say topic 1. It will land in topic 1. Someone else wants to send, you create topic 2. So that will be identified. Okay, so this guy is sending the data, that's in Q1, this is Q2. And then whoever want to consume the data, they subscribe to that queue. I will say, give me all the data from Q1. I know Q1 is coming from this side. I will get the data. So it is called a producer-subscriber model. Producers are the guys who will produce the data. Subscribers are the guy who will connect and say, give me the data. Kafka will hold it in the middle. And typically when you install Kafka in a Hadoop, it is installed in a cluster, not one machine. Because it needs to hold this data. You can't predict how many data will come. And some of the people will say, I want to hold the data for 7 days. So if 7 days the data keeps on coming, it has to hold, right? So space is required. So you need to allocate some space for Kafka to hold the data. Otherwise it will not work.
Is there any generic services for Kafka? Suppose I want to download the tweet data. Okay, that means I need to go through Kafka and I need to have some other services to go through some service.
No. Kafka can work independently also. So even though Kafka is very common on Hadoop, we have customers who are using Kafka independently. For example, there is this Nokia Siemens network. Nokia, right? Not the phone, the networking company. You have this mobile phone, right? This providers, Vodafone, Airtel. So they have a lot of equipments, router, switch, tower, etc. So the majority of these equipments are handled by Nokia Siemens network in India, at least. So we were working with them for one of their projects. So they have this telemetry data. Telemetry data means all these devices will send the data, like switch, router, their current status, etc., etc. That's called telemetry data. So that will come through Kafka. And they are not using Hadoop or anything. Kafka is just used to collect all this data. So once Kafka holds this data, they have multiple applications which will read this data and understand the data. So basically they have a Kafka cluster. They have nothing to do with Hadoop. And that is used to hold all this telemetry data, this telecom related data for them. In this example, we have Hadoop. So very commonly Kafka is found on Hadoop because it is a big data platform. You can use it independently also.
Suppose if I want to download the tweet data, then what should I do for this?
So in this architecture, if you
not
just
in this architecture, generally I'm talking about it.
So you can use Flume. So if you're simply interested in downloading the tweet, you won't need to use any big data technology. You can get it from this API, right? REST API. So there is something called REST API. Using the REST APIs, so Twitter has some rules. Previously, it was very easy to download Twitter data. Like anybody can go and say that I want the data and you'll get all the data. So now they have made their rules a bit stringent. So you have to sign up for a developer account and then you have to send a request to Twitter. They will ask like why you want to create it. Are you going to bomb the Washington or something like that? They will ask. You say yes or no. And some questions they will ask basically to identify. And then you give all the answers and they will take 2 days to review your application. Then you will say, okay, you have the access. Then you have to create an application with Twitter. And that application will have something called consumer key and consumer secret. It will generate. So that is based on your username in Twitter. Using these keys, you can create a simple web-based, REST API. Start downloading the tweets. Normal tweets. Now, if you are expecting a lot of millions of tweets you want to download and store, probably REST API is not a good idea. I can use Flume. Flume will collect it. So the source will be Twitter. Destination, ideally I will say Hadoop. It will dump it into Hadoop, all the tweets that you are getting. So first thing, they will give you all the public tweets, not private tweets. So any public tweet you can access. And you cannot, ideally you cannot go to them and say that give me all the data. That will be overwhelming. Like you will get billions of tweets, right? So you can use filters. We use filters. In the filter, you have to say what you want. So in the filter, I can say Apple. So anything matching with Apple, you will get. But the filters are not really powerful because you will get the fruit Apple and the company Apple also. All right. So then what you do? Because Twitter will say that, boss, this is what I can give you the best. Then you have to figure out from that, okay, you have to write some logic and figure out this is related to the company Apple. But you get the data first. And then you clean the data, understand this is company related data, and you can get. Very rarely people use it. But if I have to send you a tweet, which I don't want to make it public, I can do it. It won't be visible. So that we will not allow you to download. Any other public tweet you can download. Tweets come in JSON format.
So we do this all the time.
Sentiment,
Yeah,
that's what I was thinking.
That's what
Sentiment analysis is very common.
Very common, yeah.
Like last week itself, we did one on Me Too campaign. Hashtag Me Too. So that was very interesting. So it's very common to do. Okay, but I have the code, but that's in my laptop. It doesn't work. Like I can't connect. You have this machine, right? So there's a bit of code you have to do.
Based data transfer.